Welcome to this edition of Technical Quick Tips. I'm Bob Schmidt. Today we're going to talk about the high voltage power supply as it applies to small laser diode driver boards. For example, this board here requires a high voltage to charge up the capacitor bank on board, and that gives us the energy to drive the laser diode pulse. To do that, we use a high voltage power supply, perhaps like this one. And the question always is, how big of a supply do I need? The data sheet will tell us what the voltage has to be, but what about the current? Well, if we look at the textbook, we find the formula I equals C times dV over dt. This is the classic formula for determining the amount of current that you need to charge a capacitor. C is the capacitance in farads. D is the change in voltage. For example, if the capacitor is already charged to 25 volts and we wish to charge it to 100, then dV becomes 75 volts. And dt is the change in time. Now, we can simplify this formula a bit by using some assumptions. Let's assume that we're going to charge starting at 0 volts, 0 to some maximum. In that case, we'll just use V for the voltage. Now, this time increment right here is in the denominator of this fraction, and 1 over time is frequency. So we can write this formula as I equals CVF. The current that we need to charge the capacitor depends on the capacitance. A bigger capacitor requires more current, a higher voltage will require more current, and the number of times we do this per second will require more current if we increase that. CVF current is an expression that's used not only in the pulse business, but also by manufacturers of things like CMOS integrated circuits, because these components contain lots of N-channel and P-channel transistors, and when we turn those transistors on and off, we must either charge or discharge their gates, which act like capacitors, and therefore CVF current actually does comprise a large amount of the amount of power required by a CMOS integrated circuit. So we didn't invent this term. This is something that's used in industry. Let's go ahead and use an example. What is the amount of current that I need from the high voltage supply to drive something like a PCO 7110, which has a capacitance of about 1400 picofarads? That's going to come out to 1.400 times 10 to the minus 9th farads. And just to grab some other numbers, let's use 100 volts for the voltage. And to grab another number, let's say that the frequency is 10 kilohertz. That means we're going to require 1.4 milliamps from our high voltage power supply to provide enough energy to that board to pulse it at 100 volts and 10,000 times per second. That may seem like a rather low figure, and it is. It depends on the product. The 50 amp version of this board draws about 5 milliamps. There are other boards that draw 10 or 15 or 20 milliamps. As a rule, we save you this calculation by indicating on the data sheet how much current at the high voltage is required. But this way you now know the theory behind it and where those numbers come from. Thanks. Talk to you next time.